uploaded it. Okay. Hi guys, welcome to our AP Statistics project. We did our project on free throws for Mr. Sandate, and it's called Training Center with Mr. Sandate.
I'm Joey.
I'm Kenley.
I'm Calvin.
And I'm Melissa. So first we'll go through our table of contents. So our first section will be the focus question. Our second section will be data collection. Our third is data analysis and inference. And then our last section is conclusion.
So now we're gonna look at our research question. So about us, we're AP statistics students that love AP statistics, and we want to know more about probability. And we also want to know more about Mr. Sandate. And the motivation behind our test is that we saw Mr. Sandate was playing basketball at the rally, and we wanted to see how good his free throws were.
So to be more specific, our research question is Mrs. Sandate really a 75% free throw shooter? Because he believes that him personally, he is a 75% free throw shooter. But us as students, we believe that it is less than 75%.
So for our
Yeah.
test procedure, we are doing a one sample z-test. And for our hypothesis, our null hypothesis is p is equal to 0.75. And our alternate hypothesis is p is less than 0.75, where p is equal to the true proportion of Mr. Sandate's free throw probability.
And then next we'll move on to data collection. Oh, so our method we used was Google Sheets. So all of our data will be recorded on Google Sheets. And then we also collected this data in person with Mr. Sandate at the Blacktop on sometime last week. And the type is an experiment, and we will communicate our results as our conclusion.
Okay, so this is our data. Mr. Sandate made 24 out of 40 free throws. So that means he missed 16. Below is our spreadsheet for the data, and then this just shows that from the sample, he is a 60% free throw shooter.
So we analyze this probabilities and we put it on a visual representation with a pie chart. As you can see on May 14th, we showed the data. 60%, the green is made shots, and the red is 40% missed free throw shots.
Here on this slide, we have the live video of Mr. Sandate shooting his free throws.
And then next
Wait,
we'll be
wait,
going.
wait. Let's see some of the video. We gotta see Mr. Sandate
Oh
make his.
shoot, why is it not? Hold on, we'll
Just
we'll
like
edit this.
go
We'll
into the
edit
middle of it.
this.
Go into the middle of it.
It's okay, I'll just put the video
Oh,
in the thing.
Oh wait,
you
wait. No,
missed
let him
it
cook. Let
already.
him cook. Let him cook.
What? It's okay.
Okay, wait. Let him cook. Let him cook.
No, it's okay. Relax.
Wait, wait. Boo!
Hey, wait,
Boo!
he's
Oh my
actually
God.
cooking. He's cooking.
Look at Kenley. Beautiful.
Wow, Kenley's such a professional at this.
Dude, why do I look so awkward in the video?
I don't know,
I didn't
Kenley,
feel
that's
awkward.
you. What?
Okay, we can
Okay.
go to the next slide now.
So next we'll be going on to our analysis and significance test.
So P is Mr. Sandate's true free throw rate, and then for our significance level, we're doing a 5% significance level. And so that means HO is when P is equal to 0.75. So when his free throw probability is 75%. And then the alternative hypothesis HA is P is less than 0.75 because we're trying to prove that Mr. Sandate's free throw is less than 75%.
As in for the plan, we have a one sample z-test for P, which Joey said earlier what that was. And before we do the do part, we make sure the conditions are met. And for probability, one sample, we have the random condition. We need to make sure our data was collected on a completely random day at a random time to make sure that we can generalize it to the entire population, being Mr. Sandante's free throws. The next one is normality. We need to check if the data is approximately normal. And to do this, we use central limit theory. We had 40 samples, which is greater than 30, which um, which central limit theory can say that the data is approximately normal. Next up, we have the 10% condition, which is without replacement. Since 40 free throws is less than all 0.1 of all Sandante's free throws you've ever thrown, we can use the data without having replacement, and some other factors such as bias. We'll talk about that later on more.
So for the do, our specific formula for the test statistic would be Z is equal to the sample proportion minus the population proportion, divided by the square root of the population proportion times 1 minus the population proportion, divided by n, which is the sample size. So when we plug in the numbers, it is 0.6 minus 0.75 over the square root of 0.75 multiplied by 1 minus 0.75 divided by 40, and Z is equal to negative 2.19. If you want to do it on the calculator for norm CDF, the mean is 0.75, standard deviation is 0.07, with the lower bound being at negative 1000 and our upper being at 0.06 or 0.6, and that is equal to 0.01422.
Okay, so now we will conclude that assuming that HO is true, assuming that HO is true, that Mr. Sandate is a 75% free throw shooter, there is a roughly about a 0.01422 probability of him getting a free throw rate of 60% purely by chance. And because 0.01422 is less than 0.05, sorry, we can conclude that Mr. Sandate is not a 75% free throw shooter.
So now we have our conclusion. Unfortunately, Mr. Sandate is, yes, not a 75% free throw shooter, but just because we found convincing evidence that he's not a 75% free throw shooter, there were other variables that could have affected this.
So some possible confounding variables we thought up while collecting the data. During Mr. Sandate free throws, there were a lot of people yelling, such as people in the pool during seventh period. There was also a lot of audiences yelling to cheer him on, which could have influenced it in a negative way. Another confounding variable is wind. While I was catching the balls, I noticed that the ball would shift more to the right because the wind was pushing it. Another factor is the sun. Not only could have it blinded Mrs. Sandante, but the heat could have made him uncomfortable, which threw off his throws, making him miss more than average. And finally, another possible confounding variable would be pressure. As I said earlier, there was a lot of people yelling. So all those yellings could have affected Mrs. Sandante's confidence, which would negatively impact his free throw shoots.
So our takeaways from this experiment is Mr. Sandate is rusty. He was a basketball coach, but as time passed and he no longer coached the team, his skills must have declined. For future sampling, next time we'll get more samples, making the study a lot more accurate and closer to the true percentage. there's also a possible type 2 error, and that's the possibility that we rejected Mr. Sandate being a 75% free throw shooter, but we actually do not have convincing skills or convincing evidence for this. There's also a possible bias. Maybe the basketballs were sort of deflated, or maybe Mr. Sandate was having a bad day.
Thank you.
And that's
Thank
it.
you.
Thank you.
Thank you.